we'll get this right. So I had it right initially, and then I just got distracted. So let's do it again. Okay, so now we are recording. Share. Okay, so you want to break it down to perpendicular forces and parallel forces. What I mean by that is parallel to the surface or perpendicular surface. So so your applied force looks like this. It's not pure horizontal, it's not purely vertical. So you have to break it down nor vertical. So you got to write like this: F app x, F app y. And this is your angle right here. We'll call it theta. So yeah, the perpendicular forces are Fn, weight, and F app y. Your parallel forces are little fk and F app x. Directions: that goes to the right, that goes to the left, that points up, that points down, that points up. If we come back here again, the F app, you kind of have to do trig, right? So cosine theta is F app x over F app. Sine theta is F app y over F app. So F app x is the cosine theta times F app, and F app y is the sine theta times F app. So this right here is going to be F app times cosine theta, and that right there is going to be F app times sine theta. So we have to get that out of the way first. Break down the applied force in those components, figure out what forces, what directions they are, categorize them as perpendicular and parallel. You gotta get all that out of the way first. Now, so this is all the first step. Identify forces, get the direction, is a perpendicular or parallel. That's what you gotta do. Step 2. So I'm gonna erase this part. Step 2 is gotta make your equations. Make equations using Fnet. Now remember what Fnet represents. Fnet represents all the forces added up, right? So we're going to do an Fnet for perpendicular and an Fnet for parallel. Now the Fnet for perpendicular is 0 because there's no vertical motion. The Fnet for parallel, so this is Fnet for perpendicular. The Fnet for parallel is also 0 because you have a constant velocity. So, and also Fnet is going to be all the things added up. And it does equal, Fnet does equal ma, just so you know. But if you have no acceleration, it's 0. Or if it's not moving, it's still 0. So that's the reason why we could say it's 0 for both cases. Constant velocity, no acceleration, not moving, 0 acceleration. So if it's not moving vertically, 0, and of course, constant velocity horizontal, 0. So now I gotta make my equations. And so I'm gonna say Fn plus F app y, because those are both in the positive direction, but minus W equals 0. Fn plus, remember that's F app sine theta, so that's 230 times the sine of 30 degrees minus the weight due to gravity, which I know is 100 times 9.8. And because you already have a minus here, that already takes care of the negative for 9.8. Because we already know it's going in the downward direction, so you don't need to put a negative there. If you solve for Fn carefully, you should get 865. So usually Fn does equal mg if you don't have any other vertical forces. Because we had a third vertical force, F-y, I had to take that into account, which is what I forgot to do in my initial analysis. Now let's go to the parallel forces. I'm going to erase some stuff here. We don't need all this anymore. Okay, we'll stick with blue. So again, my net force in the horizontal direction is 0 because I have constant velocity, so I can put 0. And you have FFX going to the right, so that's positive. The little FK going to the left, that's negative. 0 equals your FAP, which is 230 times the cosine now, because FFX of 30 degrees, minus FK, which is mu K, times Fn. Well, I already solved for Fn from my perpendicular analysis. So if you do this 230 times cosine of 30 degrees minus mu K times 865. Solve for mu K correctly, and you should get, I could write that better, sorry, it's just really hard at Greek alphabets with the stylus on a computer screen. And you should get 0.23. So this is the wagon problem. And that's how we work it out. So you have your perpendicular analysis got to take care of, then your parallel. And really it's two major steps. Draw, or if you have the diagram drawn for you, identify the forces, put them in categories, know their directions. Some will be perpendicular to the surface, some will be parallel to the surface. Fine. And if anything's not, like the applied force, break it down to its components so you have something that's purely parallel or perpendicular and know the directions. The second step is making the equations using Fnet. Fnet is mass times acceleration, but sometimes that's going to be 0 if you don't have acceleration. If you're not moving vertically, the thing's not going up and down, A, 0. If it's constant velocity, A, 0. If there is acceleration, they'll tell you, or you may have to solve for it. I don't know. Depends what they want in the question. Once you have your equations established, then it's just solving. So I'm gonna have you guys try one of these right now because I feel like you guys need this practice. I'll put you guys in breakout rooms. So we have a record, which is great. So you guys can watch that again. Thank you for reminding me to do that. I think what I'd like to do is probably something similar. Hold on. Maybe 5 is a good one because very similar. Yeah, 5 is very, very, very similar. Yeah, let's do 5. There we go. Perfect. 5 is a great one. So I'll put you guys in breakout rooms. So let me go ahead and stop sharing, end the recording.